Hi, I want to do a couple of examples involving the velocity transformation equations. I want to do this first example, and I'm going to do these examples in separate videos. So, first example I want to consider is the following. While stationary, you observe a vehicle moving at a speed c over 2. And a person in this vehicle throws an object at a speed c over 2 in the direction of motion of the vehicle. Using the velocity transformation equation, calculate the speed you would observe. We're going to assume you're the stationary frame, the lab. Normally we call it the lab frame. Okay, we want to see what speed you would observe. So you would think that c over 2 plus c over 2 is c, but that's not the case. So I drew a picture on the board of the system. So let me explain the picture. In this picture, I've drawn you, the observer, in the XY frame. This is the frame where we would call the lab frame. It's not moving. And this is the rocket, which is moving relative to us. We'll call that the prime frame. The rocket's moving at speed c over 2, and I'm going to denote that as v sub x. And the object is thrown with a speed c over 2. I'm going to call that u sub x prime. So to calculate the velocity you would observe, all you got to do is use the velocity transformation equation. So we need to calculate, or we need to look up the velocity transformation equation in the x direction, and it looks like this. Now, again, u sub x prime, which represents the speed of or the velocity of the object relative to the moving frame, that's c over 2. And v sub x is the x component of the speed of the reference frame, which in this case is the rocket. So all we have to do now is plug in these equations. We plug in these values into the equation. The numerator becomes c. The denominator is 1 plus, this is a fourth. And we get the speed is 4/5 c. It's not just c over 2 plus c over 2, which would be the case if we didn't have these, if the Galilean transformation was valid at any speed. If the Galilean transformation was valid at any speed, the answer would be c, but we know that's not the case. And so the answer is 4/5 c. What if the rocket was moving in the opposite direction? Well, if the rocket was moving in the opposite direction with speed c over 2, you would end up getting 0. But let's change this problem. Let's let the rocket move to the left with speed c over 4 in that direction. So let's say this thing's moving backwards, okay? Let's say this whole thing is moving backwards. We're running it in reverse. Now what happens? Well, in this particular case, since this is moving to the left, since this is to the left, then we have to write v sub x as minus c over 4. And still u sub x prime is c over 2. And so we substitute these values into the equation. And this whole thing is over c squared. The numerator is going to give us c over 4. The denominator is going to give us 1 plus, or 1 minus, 1/4 and a half is an eighth. So you're going to get c over 4 divided by 7/8. That's going to give you 8 over 7 times c over 4. And in this particular case, you'll get 2/7 c.